we want to find the directional cosines for these two vectors. Even before you start the problem, you should sort of have an idea as to what we can expect with this one. If we can't visualize it. So the vector a comma 0 comma 0, where does it lie? Right here
On the x-axis.
on the x-axis. So I'll call it A. What is the angle of A with respect to x-axis? 0. Agreed? That is alpha. Alpha is simply the angle the vector forms with respect to its reference axis, which is x. Well, it's 0. What about y?
90 degrees.
90 degrees. Easy way to remember xy plane, the angle between, x-axis, y-axis, 90 degrees. I'm no artist, but that is 90 and that is 90. In any coordinate plane, the axes are at right angles. So the angle that this vector forms with respect to the y-axis has to be 90 degrees. And what it forms with the z-axis has to be 90 degrees as well. So that is gamma, that is beta, alpha, hard to do. I mean, I can write it, but it wouldn't mean anything. First step is to find the magnitude of A. What is the magnitude of A? 8. But so that we obtain the magnitude by squaring the individual components, adding them together, taking the square root. So 8. If I want a unit vector corresponding to A, what should I do?
Take the vector itself and divide it by that magnitude.
Take the vector itself and divide by A. Call it A sub u. A divided by magnitude of A. And that's going to give us A 0, 0 divided by the magnitude of A, also A, 1, 0, 0. Yes, the unit vector that corresponds to this vector is 1, 0, 0. But does that make sense? Intuitively?
Yes.
Why?
If you multiply a vector by 8, you get.
No, intuitively. Geometrically.
It's on the same line. It's on the same line.
It's on the same line. Okay, getting closer. I forgot to count. Yeah. You are getting close. So what does that mean? It's on the same line. It would mean the same direction, same
They're parallel.
magnitude. Huh?
They're parallel.
Okay, they are parallel also. Okay, so lines on top of the same line. Well, I'm sorry. We can't say parallel in a sense of definition because it is intersecting at infinitely many points, right? But what I mean parallel is that It's going on the same direction, but they're not technically parallel because they intersect at infinitely many points. But Carl said lies on the same line, I agree, or axes. But y is the unit vector corresponding to the vector a, 0, 0 is 1, 0, 0.
The unit vector is one length, but the same direction, that's
If it,
is it too simple of an answer that?
It's too simple of an answer. Think back to how we define unit vectors and
Does that have something to do with planes?
no.
No.
The standard basis. Standard basis.
Okay, what's your name?
João. João.
Joel.
Yes, kind
How
of.
do you spell it for me?
Joao.
Joao. Joel. Okay, I'll just call you Jeff.
Okay.
Super name. Standard basis. The unit vector along this axis, the x-axis, is I, right? So it doesn't matter what magnitude you have, the unit vector that corresponds to x-axis is 1, 0, 0. That point lies on the x-axis. In a way, it's just a short x-axis. Agreed? Going back to the concept of vectors, I can represent vectors of different lengths. Yes, and they might all point in the same direction. If I simply drew it this way, still x-axis, agreed? So the unit vector corresponding to this one is simply the x-axis. So makes sense that the point lies on top of the x-axis. Good? And that's why we got this. If I had a point over here, or vector over here, what would the unit vector be? When you do all the magic?
J.
J. If it's here, okay. But if it's somewhere on the plane, then you would have a combination of J and K. Yes? Okay. So we have the unit vector. Using that, we can find the angles. So cosine alpha is 1, cosine theta 0, cosine gamma 0. How do we find alpha? What function should you use in your calculator? Cosine inverse. Cosine is 1 when alpha is 0. So 0 degrees or 0 radians. Same, yes. We knew that already. The vector is on the x-axis. So with respect to its own axis, there has to be no angle. None. For what angle? Is cosine 0, 90 degrees, which is the same as pi over 2 radians. Good. Second, we want to find the unit vector corresponding to, I'll call it B, 2 minus 4, 16. So in this case, is the unit vector simply the I vector? Yes or no? Just the I vector? No. Is it simply the J vector?
No.
No. Is it simply the K vector? No. Is it simply the combination of I and J? No. Is it simply the combination of J and K? No. That leaves me with one other combination, IK? No. So it has to be the combination of I, J as well as K. Now do you understand what I meant by vectors are combinations of the standard basis, unit vectors? Okay. The magnitude of B is square root of 2 squared plus negative 4 squared plus 16 squared. 4 plus 16 plus 256. Square root of 276. You can simplify if you want. It's clearly divisible by 3. 3 times 92. Yes. This is 23 times 4. So 2. Nine. Yeah, 2 times square root of 69. Good. You don't have to simplify, you can leave it as is if you want. When you do a problem like this, easier way to check your answer. If each of those values that you find, cosine alpha, which simply is the vector B divided by its magnitude only in the first component. So let me just go ahead and divide the entire vector. Notational issues. So the vector V, excuse me, B divided by its magnitude, the same as B1, B2, B3 divided by its magnitude. B1, B2, B3, simply 2, negative 4, 16 divided by magnitude, which is 2 square root of 69. Yes? Well, I can write this as 1 over square root of 69, comma negative 2 over square root of 69, 8 over square root of 69. Yes? Because you divide each component by magnitude. So that is the unit vector that corresponds to the actual vector B. In a problem like this, if each of these components that you come up with end up being over 1, you made a mistake somewhere. Why? If this value, that value, or any one of those values, or all of them, exceed 1 or go below negative 1, you made a mistake. Why?
Because it's out of the range of the unit circle.
It's outside the range of the unit circle, in the sense it's outside the range of cosine. So that is a dead giveaway. So from this, we can write cosine of alpha 1 over 69, cosine of beta negative 2 over 69, cosine of gamma 8 over square root of 69. And what do we get?
The first one is 1.45 radians.
Okay,
The second one is about 1.81 radians. The last one's about 0.278.
good. Oh, ridiculous, maybe it's not that. If you want to express it in terms of degrees, you can simply multiply by 180 and divide by pi. Yes? If someone asked you, well, do you believe that this point is somewhat close to a plane? Will you agree with that person?
I mean, you can put a plane wherever you want, so.
True, Chase, very true.
You're
In
talking
the
about
standard
those,
case.
I mean,
Huh?
it's kind of close to one of them,
Right, it's close to one of them. Can you tell me why?
because it's only 2 units away from one of the planes.
True, but in terms of direction, it's not.
It's a small angle.
The small angle, 0.27, close to 0. So it's kind of getting closer and closer to that axis. So it's getting closer to the axis. At the same time, it doesn't, these two aren't 0. So it's not going to lie on the axis, but it's going to lie really close to which plane?
The XX.
XX.
Or sorry, not X,
So X and
sorry, this is Z axis.
Y Z.
I'm thinking, am I wrong?
X, Y.
I'm not thinking fast enough.
Right? If this becomes 0, you have only the I vector and J vector, right? So X and Y. So angle is going to become 0. Okay. You can either get the position of a vector using its components or their angles. Now, where would we use this? Well, 3-dimensional space, aviation, it's all angles, marine stuff, angles. So pretty much engineering of any sort in physics, angles. Are we clear? Any questions? No? Okay.